In the ever-evolving landscape of the automotive industry, software is integral to the functionality of modern vehicles. AUTOSAR, the Automotive Open System Architecture, is a pivotal framework that has revolutionized the development of automotive software. AUTOSAR offers a standardized framework, architecture, and methodology that is followed in the automotive industry to develop software embedded in electronic control units used in vehicles. The AUTOSAR Consortium was founded in the year 2003 as a collaborative effort by major automotive manufacturers and significant stakeholders in the automotive industry to address the increasing complexity of software and electronic systems in modern vehicles. Before this initiative, each automotive manufacturer and supplier often developed their own proprietary software solutions for different vehicle components, which led to challenges in terms of compatibility, reusability, and scalability. Adding on to this, they also faced issues with longer development cycles and difficulties in smoothly integrating different systems together. With AUTOSAR, the automotive industry can develop software in a more modular, scalable, and collaborative way. The framework does this by establishing common standards, interfaces, and methodologies to simplify software development and enhance interoperability. Through all of this, its prime focus is to drive innovations in the automotive sector forward. For a better perspective of what AUTOSAR is, let's delve into a simpler way to understand it. AUTOSAR is like a set of standardized software code blocks that car makers can use to embed and operate hardware in a vehicle. Each piece represents a specific function, like braking or engine control. These pieces are designed to fit together easily, making it simpler to create advanced software systems for cars while allowing flexibility for different models. Just as Lego blocks provide a common way to build various structures, AUTOSAR offers a common framework for building automotive software. AUTOSAR has made it possible for application software to be independent of hardware. This means that application developers can focus on building the application layer without being too concerned about the hardware it's embedded on. In this process, AUTOSAR optimizes reusability and exchangeability, as well as facilitates development in a shorter amount of time to get products to the market quicker. Moreover, software can be developed according to the AUTOSAR standard, making sure it can be scaled across a multitude of vehicles at once. This practice ensures that OEMs and suppliers can meet the surging demands of the automotive industry. Let's take a detailed look at how this standardized framework reduces software lead time in the automotive space. Before AUTOSAR was set into motion, different manufacturers and suppliers often used diverse proprietary software platforms and their own legacy codes. This posed challenges when it came to achieving compatibility and seamlessly integrating components from different sources. As software interfaces are standardized in the AUTOSAR specification, it ensures compatibility and ease of integration between different software, ECUs, and hardware components. This also facilitates interoperability and scalability, and reduces the need for custom adaptations and complex coding efforts when making modifications to existing systems. As AUTOSAR takes a modular design approach and establishes a common architecture, software can be reused across. Taking this approach reduces development efforts and accelerates integration, which also enables faster development in order to keep pace with high market demands. With AUTOSAR, manufacturers don't have to redevelop software completely from scratch each time or make changes to existing systems. When introducing new features or functionalities, it saves a lot of time. This means the duration of development cycles significantly reduces and allows them to easily accommodate changes that come with new features. In a nutshell, this promises a much faster time to market when producing software for new vehicles. In light of the increasing complexity, due to advancements in technology that require more electronic components in systems, AUTOSAR's standardized approach makes it easier to reuse the software component. Considering that AUTOSAR provides a unified framework with guidelines, it fosters collaboration among all parties involved in the process of software development to optimize innovation and shared advancements. Since its inception, AUTOSAR has evolved through various releases, each introducing new features and improvements. In the AUTOSAR framework are Classic and Adaptive AUTOSAR. Classic AUTOSAR focuses on the development of ECUs in vehicles. It provides a standardized framework for developing and integrating software components that control various functions of a vehicle, such as engine management, transmission control, and infotainment. Classic AUTOSAR aims to ensure that these software components are compatible and can seamlessly communicate with each other. Adaptive AUTOSAR is a newer extension of the AUTOSAR framework that addresses the growing need for more advanced and flexible software architectures in modern vehicles. It focuses on the development of highly dynamic and software-intensive systems, particularly those required for advanced driver assistance systems, autonomous driving, and connected vehicle services. It also supports over-the-air updates. While Classic AUTOSAR is tailored for traditional embedded control units and standard vehicle functions, Adaptive AUTOSAR is designed to support advanced and dynamic software-intensive applications, particularly those related to autonomous driving and connected services. Both branches contribute to enhancing software development, interoperability, and innovation in the automotive industry. AUTOSAR has gained widespread adoption across the automotive industry, with numerous manufacturers and suppliers implementing AUTOSAR-based solutions in their products. This adoption has led to more efficient software development, improved collaboration, and a standardized foundation for the future of automotive innovation. As the automotive industry accelerates into the future, AUTOSAR remains the essential link between innovation and a seamless driving experience. There's no doubt that the automotive industry is highly dynamic. With the prime requirement to meet stringent standards and reduce the time to market, AUTOSAR is driving advancements in software to keep pace with constantly evolving vehicle technology. AUTOSAR's architecture takes a comprehensive and modular approach, overcoming commonly faced challenges that come with developing software. With AUTOSAR, developers can now reuse, scale, exchange, interoperate, and modify their software without much hassle. It has a layered architecture that abstracts hardware from application software. The AUTOSAR architecture includes the basic software layer, the runtime environment layer, and the application layer. These are like building blocks that make up the entirety of the architecture. Let's briefly go through each layer to understand more on their role in the overall architecture, as well as how each one is fundamental in the smooth operation of software in vehicles. The basic software layer, or BSW, is the bottommost layer of AUTOSAR's architecture and lays the foundation for the rest of the software components in the system. It takes care of essential services like memory management, input-output abstraction, and operating system functions, ensuring that the software operates as per the functional requirements. It also abstracts the application software from the hardware to enhance portability and interoperability, which, as we know, is a crucial requirement in automotive electronic control units. This layer encompasses the service layer, ECU abstraction layer, microcontroller abstraction layer, and the complex device drivers layer. At the core of the basic software module is the microcontroller abstraction layer, which is crucial in hosting internal drivers that directly communicate with microcontrollers and their internal peripherals. This layer's primary objective is to abstract higher software levels from the microcontroller operations. It achieves this by establishing a standardized communication approach that aligns with the specific microcontroller in use. While it relies on the microcontroller's specifications, it serves as a bridge connecting higher software layers and the underlying hardware. The microcontroller abstraction layer is dependent on the microcontroller. The ECU abstraction layer serves as an intermediary that bridges the gap between the microcontroller abstraction layer's drivers and the functionalities of external devices like communication modules. By offering an application programming interface, the ECU abstraction layer gives peripherals and devices within the system access to software, regardless of their physical location. This layer aims to abstract the higher software layers from the specifics of the ECU hardware in order to ensure adaptability and portability. By providing a standardized interface to the higher layers, the ECU abstraction layer enables independent functionalities from both the microcontroller and ECU hardware layers. Complex device drivers, as you can see, extend over the length of the hardware to the runtime environment. These drivers have the capacity to seamlessly integrate specialized functionalities, such as legacy codes and timing-critical functions. A defining aspect of complex device drivers is their implementation, which can be influenced by diverse factors such as the application, microcontroller specifications, and ECU hardware specifics. These drivers provide a standardized interface to higher layers, offering consistency and coherence. This interface is designed to cater to various scenarios, including applications and microcontroller variations, ultimately ensuring a harmonious connection between intricate hardware nuances and higher-level software functionalities. At the very top of the BSW layer is the service layer, which is responsible for offering essential base software modules and services to applications within the application layer. This layer remains independent of the specific electronic control unit, ECU, hardware and microcontroller. The service layer oversees functions such as memory services, diagnostic services, vehicle network communications, and management, ECU state management, and operating system support. Moreover, it plays a significant role in managing the access of software to input-output signals in order to ensure effective interaction between software and hardware. The runtime environment layer is situated between the basic software layer and the application layer. It carefully manages tasks such as scheduling, resource allocation, and communication between software components. This layer plays an essential role in ensuring seamless cooperation among diverse functionalities, while making the software component portable across different ECUs. By separating the complexities of real-time execution, the runtime environment layer empowers developers to focus on high-level application logic without being too concerned about hardware complexities. In the AUTOSAR architecture, the application layer is at the very top and plays a crucial role in defining the high-level behavior of the vehicle's software system. It encompasses the diverse range of vehicle-specific applications and features, from the engine management system to advanced driver assistance functionalities. This layer encapsulates the intelligence that makes vehicles smarter, safer, and more user-friendly. By providing a standardized framework for designing and integrating applications, the application layer ensures seamless collaboration between different functionalities within the vehicle. Hardware is the block upon which software components operate. It encompasses the physical components within a vehicle, such as microcontrollers, sensors, actuators, communication interfaces, and more. The hardware's role is to provide the necessary physical interfaces for software to interact with the real world, enabling functionalities ranging from engine control to safety systems. AUTOSAR ensures the efficient interaction between software and hardware through abstraction layers like the microcontroller abstraction layer, which abstracts software from hardware intricacies. Ultimately, the integration of hardware within AUTOSAR guarantees that software instructions translate into tangible actions in order to drive the operation and performance of modern vehicles. It's evident that the AUTOSAR architecture stands as a remarkable framework with a layered structure, offering a systematic approach to managing complexity, promoting modularity, and ensuring portability across diverse electronic control units. By seamlessly integrating software components through well-defined interfaces and abstraction layers, AUTOSAR empowers the automotive industry to create safer, more efficient, and technologically advanced vehicles for the future. Classic AUTOSAR offers a standardized software architecture and development methodology that plays a crucial role in the software industry. It provides a common framework for organizing and developing software in order to facilitate compatibility across diverse vehicle models and hardware platforms. By promoting modularity, reusability, and standardized communication, Classic AUTOSAR serves as the foundation for efficient and scalable software development. Automakers can leverage Classic AUTOSAR to meet the demands of the increasingly connected and advanced automotive landscape, all the while improving safety and reducing the associated development costs. Classic AUTOSAR was developed to address the evolving demands and complexities of automotive software systems. Over the years, there have been multiple releases of Classic AUTOSAR, starting from AUTOSAR Classic Release 2.0 to the most recent one, which is AUTOSAR Classic Release R2211. These versions are developed to address evolving industry needs, introduce new features, and improve the overall architecture. They generally include minor updates and revisions to address issues and add enhancements. From Classic AUTOSAR Release 4.0 onwards, there have been significant enhancements made to achieve goals in the automotive sector. Here's a look at what these pivotal enhancements are. With the emergence of Classic AUTOSAR Release 4.0, came a well-defined layered architecture that provided a clear separation of software components and improved software organization. This release was in fact considered a significant milestone in the standardization efforts that were underway. Classic AUTOSAR's layered structure is made of the application layer, runtime environment, and basic software layer. Each layer plays a fundamental role to ensure smooth operations across software and hardware systems. This well-defined architecture enhances software organization, promotes modularity, and simplifies maintenance. As a whole, this drastically brings down software complexity and improves adaptability to the evolving automotive software demands. For more on AUTOSAR's layered architecture, check out our previous video. Classic AUTOSAR Release 4.0 also emphasized a component-based approach to software development, which enabled the creation of reusable software components in order to reduce redundancy and improve code maintainability. This approach focuses on the creation of software components as independent and reusable building blocks. Due to this, automotive software is divided into discrete, self-contained units called components. Each one is responsible for specific functions or features such as engine control, navigation, or climate control. These components have standardized interfaces that define how they interact with each other, as well as with the underlying software platform. Developers can design and test individual components separately, which reduces overall development time and effort. These components can then be assembled like building blocks to create complex automotive software systems. Together, this provides flexibility and scalability while streamlining the software development process. In order to standardize communication protocols and interfaces, Classic AUTOSAR introduced the AUTOSAR Communication Stack. This ensures consistent and reliable data exchange between electronic control units within a vehicle. As a result of this, various vehicle systems can seamlessly and reliably work together. From the Classic AUTOSAR Release 4.0 onwards, there have been significant improvements in configuration and parameterization capabilities. This allows for the adaptation of software components to different vehicle models and configurations without extensive code changes. Through this approach, adaptability to different vehicle models and configurations can be leveraged without requiring extensive code modifications. Developers can customize the behavior of software components by assigning specific parameter values to suit the unique requirements of each vehicle variant. This configurability not only streamlines the development process but also optimizes the scalability and reuse of software. It allows automotive manufacturers to efficiently tailor software components for various models, reducing development time, costs, and the potential for errors. Ultimately, this contributes to a more versatile and cost-effective software development process in the automotive industry. Classic AUTOSAR in general, and mainly Release 4.0, incorporated additional safety features and improvements to meet the stringent requirements of safety-critical systems. These enhancements are owing to the standardized communication protocols and interfaces through the AUTOSAR communication stack, which ensures consistent and reliable data exchange. Classic AUTOSAR benefited from the development of a more robust tooling environment. This functions to streamline the software development process and enhance developer productivity. Commonly used tools and software platforms for Classic AUTOSAR development include Electrobit, EB Tresso Studio, Vector DaVinci Configurator, DSpace System Desk, and MathWorks tools for AUTOSAR. This ecosystem ensures compatibility and consistency throughout the development cycle, from the time of requirements specification to implementation and testing. Classic AUTOSAR and its many releases constantly adapt to the emerging trends in the automotive industry, accommodating advanced technologies such as advanced driver assistance systems, powertrain systems, and body control systems. All of this made it more relevant in the modern automotive realm. Classic AUTOSAR is widely employed in numerous automotive systems and allows the implementation of critical functions and features in modern vehicles. For instance, it plays a pivotal role in the development of engine control systems, ensuring efficient combustion, emissions control, and optimal performance. It also underpins functions in advanced driver assistance systems, such as adaptive cruise control, lane keeping assistance, and automated braking, all of which increase vehicle safety and driver convenience. The lessons learned from Classic AUTOSAR have prompted the development of newer versions like Adaptive AUTOSAR, which address the requirements of advanced vehicle technologies such as autonomous driving and over-the-air updates. Although Classic AUTOSAR set the tone for efficiency and scalable software development, it presents several challenges such as static configurations and not supporting dynamic software updates. Its architecture, initially designed for traditional electronic control units, may not be optimized for the advanced and highly integrated computing platforms required for modern vehicles, particularly those with autonomous driving capabilities. Reconstructing existing ECUs to meet AUTOSAR standards can be costly and time-consuming. Also, adapting to Classic AUTOSAR's component-based approach and configuration methodologies may require significant training and expertise for development teams. With this in consideration, transitioning to more adaptable and high-performance frameworks like Adaptive AUTOSAR reflect the industry's response to the automotive landscape of connected and autonomous vehicles. Adaptive AUTOSAR emerged to complement Classic AUTOSAR by providing a framework better suited for these advanced automotive systems. It offers enhanced flexibility, real-time capabilities, and scalability, as well as increased connectivity and high-performance computing platforms. Next, we'll dive into everything you need to know about Adaptive AUTOSAR to understand the flexibility and high-performance features it offers to keep up with emerging technologies and dynamic updates. As electric vehicles and autonomous driving take center stage in the automotive industry, Adaptive AUTOSAR is the answer to the increasing complexity of these modern vehicles and the demand for advanced features. Adaptive AUTOSAR is an open and standardized automotive software architecture designed to facilitate the development of high-performance, safety-critical, and scalable automotive software for the next generation of intelligent and connected vehicles. As vehicles harness the power of Adaptive AUTOSAR's service-oriented architecture, it offers a flexible framework that effectively manages resources, promotes real-time adaptability, and enables the integration of advanced technologies. Moreover, Adaptive AUTOSAR is scalable and adaptable, allowing automakers to meet the constantly evolving demands of the highly competitive automotive industry, as well as efficiently incorporate new technologies and features into their products. The shift to Adaptive AUTOSAR was motivated by the inherent limitations of Classic AUTOSAR that are characterized by its static and component-based architecture. Upon recognizing the need for greater flexibility and adaptability, the automotive industry embraced the evolution to Adaptive AUTOSAR. Adaptive AUTOSAR, in stark contrast, embraces a service-oriented architecture, a paradigm better suited for managing dynamic and event-driven interactions between software components. This shift enhances the system's responsiveness and facilitates seamless communication among various software entities. At the core of Adaptive AUTOSAR are services, which are self-contained, reusable software modules designed to execute specific functions or deliver well-defined capabilities. These services play a pivotal role in enhancing modularity and fostering efficient, specialized functionality within the automotive software ecosystem. Services are the building blocks of the service-oriented architecture that exhibit a broad spectrum of functionalities, spanning from the processing of sensor data to the implementation of intricate vehicle control algorithms. The versatility of these services underscores their pivotal role in addressing a wide array of automotive software needs. The life cycle of Adaptive AUTOSAR services is meticulously defined, encompassing key phases such as initialization, activation, deactivation, and termination. This robust life cycle management ensures that services can be seamlessly started, stopped, and adapted, effectively accommodating dynamic changes within the system. It forms a critical foundation for the system's agility and responsiveness. Furthermore, the architecture has supervision and monitoring mechanisms embedded to oversee the health and performance of services. These mechanisms can identify and respond to service failures or deviations from expected behavior, which contributes to system reliability. Next comes the service interface. Each service exposes one or more service interfaces. At its core, a service interface in Adaptive AUTOSAR acts as the blueprint, outlining methods, data structures, and communication protocols. These elements form the foundation through which other services or components seamlessly interact with the service. The standardization achieved through service interfaces ensures a well-defined and uniform communication protocol, fostering interoperability across the diverse array of services within the automotive ecosystem. There's a repository that manages information about available services and their interfaces. It serves as a registry where services can be discovered and accessed by other services or components. This promotes interoperability and dynamic service discovery. Critical to the success of Adaptive AUTOSAR's service-oriented architecture is its robust communication infrastructure. This infrastructure serves as the backbone, facilitating efficient and reliable communication between services. This infrastructure supports various communication mechanisms, including message-based communication and publish-subscribe patterns, to cater to different communication requirements. There is also resource management, that is tasked with overseeing resources such as CPU, memory, and network bandwidth. Due to this, there can be dynamic allocation of resources that align with real-time requirements. This resource optimization is crucial for supporting advanced features. The architectural transition to Adaptive AUTOSAR has ushered in a new era for the automotive industry, offering a multitude of advantages that effectively address the challenges previously encountered with classic AUTOSAR. Let's briefly explore the key benefits of Adaptive AUTOSAR. Adaptive AUTOSAR offers more scalability than classic AUTOSAR, and is efficient in accommodating the evolving complexities of modern vehicles, including electric vehicles and those equipped with advanced driver assistance systems. The architecture's flexibility enables the introduction of additional services to support new functionalities without the need to re-engineer the entire system. Adaptive AUTOSAR's dynamic adaptability allows for real-time adjustments based on changing environmental conditions, which is a critical feature for scenarios like autonomous driving. Services can be dynamically configured or reconfigured during runtime, which promotes adaptability and responsiveness to real-time changes. Adaptive AUTOSAR marks a departure from classic AUTOSAR's rigid communication stack. Instead, it embraces Ethernet-based communication, introducing a more flexible communication management stack. This shift not only accommodates the high bandwidth, demands of modern automotive applications but also enhances adaptability, reflecting a key improvement over the limitations of its predecessor. Resource allocation efficiency is also improved through proper resource management. This in turn optimizes CPU, memory, and network bandwidth allocation based on real-time needs. Efficient resource management is crucial for resource-constrained embedded systems in order to ensure optimal system performance. Adaptive AUTOSAR also addresses security and integrates mechanisms for secure communication, authentication, and authorization. This heightens security, protects sensitive data, and ensures secure service interactions, which addresses cybersecurity concerns associated with increased vehicle connectivity. The software-oriented architecture in Adaptive AUTOSAR champions interoperability among software components by leveraging standardized interfaces and protocols. Adaptive AUTOSAR's emphasis on standardized interfaces not only encourages but actively facilitates the integration of diverse software modules from various suppliers. This approach fosters a collaborative and open ecosystem, reducing vendor lock-in. Adaptive AUTOSAR's communication mechanisms, notably featuring message-based communication, form a crucial aspect of its dynamic framework. Within Adaptive AUTOSAR, communication extends beyond traditional methods, incorporating sophisticated publish-subscribe patterns facilitated by Ethernet-based protocols designed to effectively address the high bandwidth and low latency communication demands inherent in modern vehicles. This capability is crucial for advanced features like sensor fusion, over-the-air updates, and infotainment systems. The architecture's service encapsulation simplifies maintenance and software updates, allowing for the isolation of issues, application of patches, and introduction of new features, without impacting the entire software stack. Adaptive AUTOSAR's service-oriented architecture enables the seamless integration of emerging technologies and services as the automotive industry evolves. This ensures that vehicles remain competitive and adaptable to emerging technologies such as 5G connectivity, artificial intelligence, and advanced sensor suites. Given the array of benefits that Adaptive AUTOSAR brings to the table, it finds practical applications in a range of real-world automotive scenarios. For instance, it powers the brains of autonomous vehicles, enabling them to process sensor data, make real-time decisions, and navigate complex environments safely. It also underlies ADAS features that enhance vehicle safety by providing features like adaptive cruise control and lane keeping assistance. Adaptive AUTOSAR plays a pivotal role in shaping the landscape of modern infotainment systems in automobiles. Its adaptive architecture is instrumental in delivering intuitive user interfaces and seamlessly integrating connected services. Aside from all the advantages, it's worth mentioning that as with any emerging technology, Adaptive AUTOSAR still faces a number of challenges. These are associated with its smooth adoption, implementation, and integration into vehicles. Here are some of the current challenges that the automotive industry is facing with Adaptive AUTOSAR. As Adaptive AUTOSAR introduces a more complex software architecture compared to classic AUTOSAR, automakers and suppliers may face a learning curve when transitioning. This can lead to delays and potential implementation errors. The industry can tackle this by providing the right training and resources to help engineers and developers become proficient in Adaptive AUTOSAR. They can also promote collaboration with experienced Adaptive AUTOSAR consultants or seek guidance from experts in the field to streamline the learning process. Migrating from classic AUTOSAR to Adaptive AUTOSAR, or integrating Adaptive AUTOSAR with other legacy systems, may require significant effort and resources. Instead of addressing it altogether, planning a phased migration from classic AUTOSAR to Adaptive AUTOSAR, and allowing time for adjustments and testing can help with a smooth transition. Also, having rigorous testing and validation processes can ensure seamless integration and functionality. While adaptive AUTOSAR's dynamic adaptability and resource management capabilities provide significant advantages, it's important to note that these features can be resource-intensive, potentially necessitating more powerful hardware components. This consideration may impact production costs and should be weighed against the benefits of the enhanced functionality. To combat this, engineers and designers can optimize software to make efficient use of resources and consider selecting hardware components that align with adaptive AUTOSAR requirements. Despite its benefits, ensuring the seamless integration of various components, software modules, and services from diverse suppliers remains a challenge in adaptive AUTOSAR. Interoperability complexities require careful consideration to achieve harmonious collaboration within the automotive ecosystem. Standardization efforts are ongoing, but compatibility issues can arise at any phase, which hinders overall interoperability. Through close industry and supplier collaboration, automakers can improve compatibility. Adaptive AUTOSAR systems must implement robust security measures to protect against potential cyber attacks and safeguard sensitive data. Addressing integration challenges in adaptive AUTOSAR involves implementing a security by design approach. Regular security audits can also be conducted to identify and address vulnerabilities. The automotive industry has strict regulatory requirements and safety standards in place, which means that adaptive AUTOSAR systems will have to comply with these standards. To get to a point of compliance is, however, time-consuming and complex. By engaging with regulatory bodies and standards organizations early in the development process and maintaining thorough documentation of the development process can help meet compliance requirements. During the transition from classic AUTOSAR to adaptive AUTOSAR, automakers may encounter the need to support both architectures simultaneously. This coexistence phase demands careful planning to ensure a smooth transition without compromising the functionality and performance of existing systems. Managing this transition phase can be resource-intensive and require careful planning. Automakers can develop a clear roadmap for the transition from classic AUTOSAR to adaptive AUTOSAR. Also, support can be provided for both architectures during the transition phase to minimize disruptions. A robust ecosystem of suppliers and tool providers is essential for the success of adaptive AUTOSAR. Dependence on a limited number of vendors can pose risks in terms of support and service availability. Working with multiple vendors and tool providers to reduce dependence on a single source and establishing long-term partnerships with reliable suppliers who are committed to supporting adaptive AUTOSAR is a good way to work around this. Some critical automotive functions such as ADAS and autonomous driving demand high performance and real-time capabilities. Ensuring that adaptive AUTOSAR can meet these requirements without compromising safety is a significant challenge. Continuously optimizing software components to meet real-time requirements without compromising safety, and choosing hardware platforms that can provide the necessary performance for critical functions can ensure maximum safety. Developing and implementing adaptive AUTOSAR systems can be costlier initially compared to traditional architectures. Balancing these costs with the benefits of increased functionality and adaptability is a consideration for automakers. This can be tackled through a careful cost-benefit analysis to justify the initial investment in adaptive AUTOSAR by considering long-term benefits and increased functionality. As the automotive industry remains committed to adopting technological advancements, it's clear that adaptive AUTOSAR's dynamic software architecture will be key in paving the way. With adaptive AUTOSAR at the forefront, it's important for engineers to stay relevant and have a deep understanding of it to build these robust systems. In the next video, we will take you through all there is to know about how you can upskill yourself and develop industry-relevant skills in AUTOSAR. Over the course of this series, we've comprehensively explored AUTOSAR, from its very basics in architecture to its evolution from classic to adaptive AUTOSAR. We've also uncovered how AUTOSAR is vital for fueling the software-driven revolution in the automotive space with the emergence of electric and autonomous technologies. In this video, we'll take a look at the pressing need for engineers to upskill in AUTOSAR to stay competitive and relevant in the rapidly evolving automotive industry. As vehicles continue to incorporate advanced technologies like autonomous driving and connectivity, expertise in AUTOSAR has become crucial for developing safe, efficient, and innovative automotive software. Upskilling in AUTOSAR not only opens up new career opportunities, but also enables engineers to contribute effectively to cutting-edge automotive projects. This will undoubtedly keep them at the forefront of industry advancements. In addition to this, upskilling in AUTOSAR enhances an engineer's ability to adapt to changing industry standards and technological shifts, ensuring long-term professional success and job security in the automotive sector. The job market for skilled AUTOSAR engineers is robust and growing due to several key factors. First, the automotive industry is increasingly relying on embedded software to power advanced features like ADAS, autonomous driving, and connectivity. All of this creates a high demand for engineers with AUTOSAR expertise to develop and maintain these systems. Second, as vehicles become more complex and software-intensive, there is a pressing need for professionals who can ensure the security and efficiency of automotive software without compromising on safety. Adding on to this, AUTOSAR is a globally recognized standard, which means that engineers with proficiency in this framework automatically become valuable assets for automotive companies. With the right set of upskilled engineers, companies can meet international regulatory requirements and compete in the global market. As a matter of fact, engineers with demonstrated expertise in AUTOSAR are in high demand. This expertise can lead to career advancement, including promotions and leadership roles, as companies seek skilled professionals to lead AUTOSAR-based projects. Moreover, upskilled AUTOSAR engineers are better equipped to adapt to evolving industry standards and technology trends. This in turn reduces the risk of job displacement and ensures long-term job security. Now the question arises, how can you upskill yourself in AUTOSAR? Learn the basics. For starters, you can begin by gaining a strong understanding of AUTOSAR's architecture, concepts, and terminology. This can be done by studying introductory materials, reading AUTOSAR documentation, and exploring online resources dedicated to AUTOSAR fundamentals. Hands-on experience. Next comes hands-on experience. You can actively seek out opportunities to work on AUTOSAR-based projects. These can be within your current job or personal projects. Hands-on experience is considered to be one of the most effective ways to widen your knowledge and understanding. Formal training programs. You may also consider enrolling in formal training programs or workshops that focus on AUTOSAR. Specific tool vendors and training institutions provide in-depth knowledge and hands-on practice on all there is to know about AUTOSAR. Online resources. Leveraging online tutorials, forums, and communities dedicated to AUTOSAR are another one of your options. This lets you participate in discussions, ask questions, and share knowledge with others in the field. With this mode of learning, you'll get to work through problems yourself, as well as pace the speed at which you learn. Documentation and standards. It's important to familiarize yourself with AUTOSAR documentation and standards. Explore official AUTOSAR specifications and guidelines, as they serve as crucial references for AUTOSAR development. Tool familiarity. You can also get comfortable with the software tools commonly used in AUTOSAR development, such as configuration tools, code generators, and debugging tools. Practice using these tools in real-world scenarios to enhance your proficiency. Collaboration and mentorship. Another effective mode of upskilling is collaborating with colleagues and peers who have AUTOSAR experience. Learning from others and seeking mentorship can accelerate your understanding and provide valuable insights. Continuous learning. AUTOSAR, like many technology domains, is continually evolving. Staying updated with the latest developments, new features, and updates to the AUTOSAR standard is therefore important. This can be done by regularly reading industry news and attending relevant webinars or conferences. Certifications. You may also consider pursuing AUTOSAR-related certifications or courses that offer certificates. These certifications can validate your expertise and make you more competitive in the job market. By following these practical steps, engineers can systematically upskill in AUTOSAR, becoming proficient in this critical framework for automotive software development. This expertise is not limited to just their careers, but also extends to the continued success and innovation of the automotive industry. Over the years, engineers with the right skills in AUTOSAR have played a central role in facilitating the development of cutting-edge automotive software technologies. They have leveraged their AUTOSAR knowledge to make the process of software integration into vehicles streamlined and seamless for maximum compatibility and reliability. For instance, in the popular Advanced Driver Assistance Systems division, AUTOSAR-savvy engineers have effectively designed software architectures that enable seamless interaction between sensors, control systems, and vehicle components. Similarly, in connected cars and autonomous driving, AUTOSAR experts have harnessed the framework's modularity to efficiently integrate infotainment systems, over-the-air updates, and complex autonomous driving software stacks. This expertise has paved the way for innovations that are shaping the future of the automotive industry, making vehicles smarter, safer, and more efficient. It's evident that with AUTOSAR, automakers and suppliers keep in line with the industry's rapid evolution, ensuring that vehicles are not only safe and reliable, but also equipped with the innovative features and functionalities demanded by today's consumers. With more advancements in software technologies, there's never been a more compelling time to upskill in AUTOSAR. By acquiring expertise in this critical framework, you're not just staying relevant, you're positioning yourself as a valuable asset to the industry's future. The demand for skilled AUTOSAR engineers is soaring, and this expertise opens doors to exciting career opportunities and job security in a dynamic field. Getting hands-on AUTOSAR expertise will have you shaping the future of mobility, as well as being a driving force behind safer, smarter, and more connected vehicles. Take the step today to put yourself at the forefront of automotive excellence.